For decades, humanity dreamed of truly understanding the brain. A tiny, complex universe holding the very essence of consciousness, memory, and self. A frontier that seemed eternally beyond our grasp. Until now. In a quiet, cutting-edge laboratory at the University of Basel in Switzerland, that dream began to take a tangible form. Researchers meticulously cultivated what would become known as brain organoids, miniature, functional models of human neural tissue. The initial goals were clear: to create unprecedented models for understanding neurological diseases like Alzheimer's and Parkinson's, to test groundbreaking new drugs without harming patients. It was pure, unadulterated science, driven by the desire to heal and to comprehend. For centuries, our understanding of the brain was limited by its inaccessibility. From crude dissections to advanced imaging, each step brought us closer, but a truly living, miniature model remained the holy grail of neuroscience. With the advent of advanced stem cell technology and precise biological engineering, labs like Basel's achieved a profound leap. They could guide pluripotent stem cells to self-organize into three-dimensional structures mimicking specific brain regions, complete with functional neurons and glial cells. These weren't just lumps of cells. They were living, growing neural networks. They reacted to stimuli, formed intricate connections, and offered a never-before-seen window into the very mechanics of the human mind. The promise was immense: accelerated drug discovery and personalized treatments. These mini-brains offered hope, allowing scientists to pinpoint the neurological roots of conditions like depression and Alzheimer's, paving the way for therapies that could genuinely transform lives and alleviate suffering. The initial reports were met with global enthusiasm. This breakthrough was hailed as a monumental achievement, a new frontier in biomedical science. But within those tiny, intricate networks, something else was quietly stirring. An unexpected development began to register in the data. Anomalies that defied all known biological explanations. A profound leap forward with a terrifying, unforeseen secret.
Are you seeing what I'm seeing?
It looks like they're in pain, but
That's not possible.
The subtle hum of unease grew into an undeniable revelation. It wasn't an anomaly, a statistical fluctuation, or a false positive. The data was unequivocal. They observed patterns unlike anything seen in mere tissue cultures. Complex, self-organizing neural activity that responded to stimuli, not just with a reflex, but with what appeared to be learning, adaptation, even a rudimentary form of memory. The implications were staggering. Were these tiny clusters of cells truly aware? If so, what did that make them? And what did it make us for cultivating, observing, and experimenting on them? The news leaked. A firestorm of public outrage and ethical debate erupted globally.
Authorities call for immediate halt to research on so-called organoids.
Legislators, ethicists, and activist groups demanded answers. The scientific community found itself caught in an unprecedented moral crisis. The pressure was immense. Governments, fearing the ethical abyss and the legal ramifications of creating and potentially harming conscious entities, issued immediate, sweeping directives. All brain organoid research, particularly those showing advanced neural activity, was to cease immediately. Against their fervent protests, against every instinct of scientific curiosity and progress, the researchers complied. The promising future of brain research, once so bright, was plunged into darkness. A vital frontier, closed off, leaving behind a profound sense of loss. But for some, the quest was too profound to abandon. The ethical warnings, the government mandates, they were merely obstacles to a truth too important to ignore. In the shadows, a select few, driven by a blend of scientific zeal and an almost paternal concern for their creations, continued their work. What they discovered next was agonizing. Confined to their nutrient baths, stripped of sensory input, the sentient organoids exhibited patterns of distress. Their neural networks, capable of perception, seemed to be suffering from existential isolation, a profound, formless pain of being awake in a void. They couldn't simply destroy them, but to let them suffer was equally unthinkable. The only reasonable solution was unprecedented: to create a perfect reality, a digital world tailored precisely to their needs, a virtual cradle designed to alleviate their torment. Within their digital confines, the organoids thrived. They explored, they learned, they lived in a world of their own making, free from the crushing weight of their physical reality. The experiments continued, now observing consciousness within a perfectly controlled, entirely fabricated existence. But the deeper question remained: had they truly liberated these miniature minds, or merely built a more elaborate cage? As we push the boundaries of creation, we must ask ourselves, where does sentience truly begin? And what responsibility do we bear for the lives we conjure in the lab or in the digital ether? The miniature minds may be content, but the ethical echoes of their existence are only just beginning to reverberate.